This is a short video to talk about limits involving infinity because there's a couple of problems on the 2.8 webwork that involve limits involving infinity that we didn't get a chance to talk about this too much in class. So I thought I would make this little video to supplement your own reading of the textbook. So here's the idea. A limit involving infinity is one where something is getting really big, whether that be the output value of the function that we're interested in or whether that be the input value that we're feeding into the function. So let me give you a little example of this. Think about the graph of f of x equals 1 over x. Looks like this. You can see a couple of places where things are getting really big. So in particular, as x approaches 0 from the right, the function values get bigger and bigger, and just like keep getting bigger without any possible bound. Similarly, as x approaches 0 from the left, the function values go like down and down and down, so big that they exceed any possible bound below. So we might ask the question something like, what's the limit as x approaches 0 from the right of f of x? And I think that a sensible answer to this question is infinity. Because as x approaches 0 from the right, our function values go up and up and up and up and up forever and ever without any possible bound. Similarly, I think that a sensible answer to this question, the limit as x approaches 0 from the left, is negative infinity because the function output values go down and down forever without any possible bound. We might similarly ask, what happens to the output values of the function as x gets bigger and bigger forever? So you can kind of imagine following this graph, as x gets bigger and bigger, you can see the function values get closer and closer and closer to 0. So we might answer this question with the answer 0. And similarly, we might ask, what happens as x gets like bigger and bigger negative forever? So what happens as x goes that away forever? And similarly, we can look at the way the graph is going and say, well, those function values are getting closer and closer and closer to 0 as well. So that's what limits involving infinity are all about. They're about something getting really big and seeing what happens. Oops, I don't need to erase these out. So that leads us to another indeterminate form. Just like 0 over 0 is an indeterminate form with two forces fighting, for similar reasons, infinity over infinity is also an indeterminate form. These are also opposing forces. The infinity in the numerator wants to pull our answer up to infinity, bigger and bigger. The infinity in the denominator wants to pull our answer down to 0. So again, these forces are like in conflict, and the answer to the question is like, whoever is going faster is who's going to win. So here's another version of L'Hopital's rule, one involving infinity. So if f and g are differentiable, and either both of them approach 0, and you get the 0 over 0 indeterminate form, or both of them approach infinity, so you have the infinity over infinity indeterminate form, you can apply L'Hopital's rule and replace both of the functions with their derivatives. I hope that helps make sense of the few remaining webwork questions on 2.8 that we didn't specifically address during class. I might also point your attention to activity 284. This is another good one for you to investigate, like, when is L'Hopital's rule applicable, when can we use it, and when can't we? I hope that you have a good fall break, and I'll see you after that.